Um, yeah, so the whole idea is it's a way of building APK packages or APK-based container images. So you can see here I have code, which I think a lot of us have written in various forms with Dagger, with Docker files, so on and so forth, where you just want a base image or whatever, and you're using Alpine, so you get the Alpine base image, and then you go and call APK add to add the packages. Pretty straightforward. Which, often works, but there's a lot of problems with this. And this is something that ChainGuard, startup, and they're doing all sorts of things in like the supply chain security space. They've been doing a lot of really great work on. And so I'm going to show off a little bit, basically a way of using some of their tooling to improve on this. But first, like, what are the actual problems with this? So it kind of comes down to caching. So actually, I have here, if you go right now and look at the latest Alpine 318.4 image, you can see actually just on Docker Hub that there are some vulnerabilities there. They haven't updated their base image yet in OpenSSL. And this actually impacted Dagger recently because we use Alpine as a base image for our engine. And so then we started getting scan, alerts saying that there's a high vulnerability in our image. And so then initially when I was looking at it, it wasn't exactly clear why we wouldn't be getting, just the latest version of everything that's updated. But part of the problem is that we were just using this base image and they haven't updated it yet. So that's one thing. Another thing is that, like, let's say that even that they did update that, but we didn't change anything in our code. So our code that was building that's a little more complicated, but ultimately it's basically doing the same thing. But the problem is caching. And obviously caching is generally a good thing, but in this case, because we're only caching based on here's the list of packages you gave us, here's the base image that you gave us. If nothing changes, then it's going to be cached. Dagger is going to give you the same result. What we really want is, hey, let's go and look at all of the latest packages that are in actual Alpine, like their repository, because this vulnerability was fixed in the actual Alpine repository, like I think just a few days ago. But because of caching, we're not going to actually pick that up. So that's a problem. And so, yeah, ChainGuard has tools to help out with that, something called APKO, which basically it'll build a container image for you from a list of Alpine packages, but it's always going to go and look and see, oh, here's the actual latest version of the package. I'm going to use that. It's not going to just, assume that because the name of the package is the exact same, it's going to just reuse that. So that's the whole problem. And so you can see this. So I have legacy build here, and then I'm using a Trivy module that Jeremy created. And so if I go and call command, so I'm going to do Dagger call scan. And so what I'm saying is go use legacy build, because I'm setting legacy true, to build this container image with just curl installed, and then scan it. And then we should go and see that there are indeed those vulnerabilities that we saw in Docker Hub 2. There you go. You can see those. Okay, and so now I'm going to just disable legacy. So I'm going to go and do this other non-legacy build. So this is the one where I'm using so it's a Go APK package from ChainGuard. And I'll explain how this is actually working in a second, but I just want to show this. So now I'm going to go and scan it, and doing a little extra work, you can see flying by. Now it's scanning. And then see, okay, so now there are no vulnerabilities. So now what's actually happening underneath the hood here? So I can do Dagger shell. And so what I'm going to do is I'm going to open a shell with this container image that I'm building, not in the legacy way. I'm going to install packages, just curl for right now, but I could specify more. I also have this extra flag that kind of just helps with the demo where it's just going to include a little extra information inside the container image that's helpful. So now I'm in this shell. I can see it's Alpine 3.18.4. You can do curl. So that's all there. So what was actually happening underneath the hood, if I go and so this would not normally be here. This is just included because I set debug to true. So what we did is we used their library to basically go and gather all of the latest, packages for this release of Alpine. So that's kind of what's happening up here. Sort of a little boilerplate of like, you got to go get their keys, you got to go and then take a list of packages, and then their library will say, okay, here's the actual full dependency DAG, curl is not, you can't just use curl by itself. And so that's what I'm showing here is that, so you can see under here, these are all of the packages that got installed, but rather than showing them all just underneath the root of S, I'm showing each of them individually. So I can go and look at curl and I can see there's some APK metadata, and you can see this is what's actually getting installed. That user bin curl is what actually is showing up in the rootfs here. But you can see also, all sorts of other dependencies. And I believe the vulnerability was specifically with libcrypto and OpenSSL. So what we're doing, taking all of these packages, unpacking them, and that's what you're seeing here. These are just the unpacked, raw tar files that contain the actual build package. And then we're using something in BuildKit called mergeop to combine them all together. And so mergeop specifically is kind of interesting because you can take a whole bunch of inputs. And actually, I have a diagram from something I wrote a while ago to sort of help explain this a little bit. So mergeop is, part of this is all underneath the hood. It's not something you need to be aware of as a user of Dagger, but what we're doing for you is taking all of your inputs and then combining them together layer by layer to build the image. So we can actually, you can see in the code here, I'm starting with a completely blank container. I'm not doing container from or anything like that. It's just, basically starting from scratch. And then the code you're seeing here is using Dagger to get that package tar, unpack it, and then this is where mergeop kicks in. It's all kind of underneath the hood. It's just an optimization. But I'm saying just layer by layer, assemble the container image using those unpacked packages. And then that is the package, that's the container that you get at the end. So that's pretty neat. And mergeop has all sorts of really nice optimizations over just like a standard Dockerfile copy or something like that. One of them is that it uses hard links instead of actually copying on disk, which for use cases like this actually can start to matter because if you use copy, then you basically have a whole chain of operations. And if any one thing in that chain is modified, everything else after it is going to get invalidated. So when you're dealing with these big complicated package tags, you can end up with, you add just one little package somewhere, and now the whole chain is different and everything gets invalidated. So you end up copying tons of data if you have just slightly, different variations on what packages you're installing, which at a certain scale can actually get to be like a huge bottleneck. So that's one optimization. And another really cool optimization here is that it works with remote references. So if all of the operations here were remotely cached, then you actually don't necessarily need to pull them locally. So if you wanted to push this image somewhere and it turns out you've already pushed an image that had, the curl package and all of its dependencies pushed to that registry, you don't need to necessarily go and repush those. You don't even necessarily need to go and repull those. You can just rebuild the packages that you need that don't exist in the remote and then only push those. So it lets you basically be completely optimal in terms of here's exactly what changed in my image. I'm going to go and get just those packages, just those layers, and then just push those. So yeah, like I said, this is a very like just kind of quickly thrown together experimental module. I really just wanted to validate the idea, but I think it's super cool because like ChainGuard has been doing so much great stuff here, and I've been interested in figuring out how we could combine it with Dagger and all the cool caching stuff that we have. And it worked. It actually worked really well, and it's really not that much code at the end of the day, and it's super easy to play with and try out thanks to Zenith. So. Um, yeah, like this exists now. Definitely take a look at it. And honestly, what I'm really hoping is that this can be a seed sort of for more people to, um, iterate not only on this, but I would love to see this for all sorts of packaging systems. I think ChainGuard made it really easy for us because they have this great library, but it'd be super cool to see this for Debian, for Ubuntu, honestly, even other, language packaging systems like Go modules and Node modules, which are a lot trickier, but it would be really interesting to see what we could do with this sort of concept there too. Yeah, yeah, not the flashiest demo, a little technical and thrown together quick.